We also need to practice writing base dissociation reactions. Some of these reactions are simpler because when we look at the base, it's very clear to see that the hydroxide ions dissociate. The challenge here is recognizing what the base is. So when we have calcium hydroxide, we have to recall that calcium is Ca2+. So calcium hydroxide needs 2 hydroxide ions. So we have OH minus, and we're going to need 2 of those to balance out the charges. When we look at the dissociation reaction, we're going to have calcium hydroxide dissolves in water and forms calcium ion and 2 hydroxide ions. So it balances out. Both sides of the equation are balanced. Now let's do another example where we have potassium hydroxide reacting with water. We have to remember what potassium ion is, and it has the element symbol of K. If you look on the periodic table, you'll see that it has a +1 charge, which means we have potassium hydroxide reacting with water to form potassium ions and hydroxide ions. And we have a coefficient of 1 here because there's only 1 hydroxide ion in potassium hydroxide. Now let's do another example, and I'd like you to try this one more on your own. Strontium hydroxide reacting with water. So you recall what strontium is. Strontium. And you look on the periodic table and you see that it has a +2 charge. So if it has a +2 charge, then we're going to need 2 hydroxide ions, dissolve it in water, and we're going to get 2 hydroxide ions. This becomes important when we start doing calculations with strong bases. And these are all examples of strong bases. That we know how many hydroxide ions we get for every 1 mole of potassium hydroxide, we'll get 1 mole of hydroxide ions. For every 1 mole of strontium hydroxide, we'll get 2 moles of hydroxide ions. Being able to figure this out becomes very important when we start doing the calculations on pH and pOH and how acidic and how basic our solutions are. Let's look at another base, ammonia. Ammonia is a base, it's a well-known base, but it doesn't have an OH group. How can this be? Well, think back to our definitions of what an acid and a base were. An acid was defined as a proton donor, and a base was defined as a proton acceptor. So when we take the reaction with ammonia, we have ammonia reacting with water. It accepts a proton. And what we're left with is an OH group, which makes this a base. In this case, water is acting like an acid because it donates a proton to the ammonium ion. It's harder to recognize weak bases, and this is an example of a weak base. It does not dissociate completely. Typically, we will tell you what they are.